Hello everyone. In today's video, I'm going to talk about how to solve linear system. As you can see, there's many ways to solve a linear system. Take this as an example. I know it's really easy to solve this problem, but let's imagine that there's a lot more unknowns, say 8, 10 or 20 unknowns. This problem will be quite difficult to solve, and it's also time consuming. Of course, you can use the Matlab building function to solve this kind of problem. But however, I only focus on Gauss elimination method for this video, and then I will apply this method to the Matlab code. Now let's take a look at the concept of this method. To solve the problem, we have to put the system here into a matrix. I call this matrix A, and matrix and the vector B. The value in this vector is taken from the value from the right hand side of the system. And then we combine these matrix and vector into a matrix which is called augmented matrix. Now I want to mention a little bit of the rule for solve the system using this method. The first is rows are interchangeable. For example, I change the row number 3 to row number 4 and row number 4 to row number 3. Even though we change this order, the solution of the system is not affected. So we can use this rule to apply to the method of the solution. Next, the multiplication by a non-zero constant can be used to any row of the matrix. For instance, in this case, I multiply the row number 4 by a constant number is number 5. So it will change to the new matrix, but the solution still stay the same, so it doesn't affect at all. The last rule is the important rule of this method. We can do the subtraction of one row from another row. For example, I change the row number 1 by using the row number 1 subtract 2 multiplied by row number 4. So in this case, the number 9 minus 2 multiplied by 8, and so on for each row, for each column of the first row here. So we'll change into the new augmented matrix as well. Now let's take a look at the concept of this, the idea of this method. So the final idea is to get the augmented matrix to the matrix look like this. I mean, we will change the matrix A here into the upper triangular matrix, so that we can solve the problem easily after that. But first, how can we do this? So we will start from eliminating the first column of each of the second, third, and fourth row of the matrix. So to do this, the row number 2 will change to row number 2 minus 5/9 multiplied by row number 1. The number 5 here we take from the value of the number that we want to eliminate from row number 2, and the 9 value here is taken from the row number 1, and this also applies to the row number 3 and number 4, and we will change we can get the zero value in the first column of row number 2 to row number 4. But remember that when we do this subtraction, we need to do all the column of each row here, so that the result will stay the same. Next, we do this also, but we only apply to the row number 3 and row number 4, and then we change the row number 4 for the last part. So we got this upper triangular matrix, and then we can use the back substitution to solve for the value of, in this case it's z, by take the value here divided by the value here. So we got the value 7 for the unknown z, and next we can solve for y from the row number 3 by using the solution from row number 4, and so on. We can solve for the system, and we got this solution. Now you get the idea, so I will go on to the Matlab code. I wrote this as a function. I named this Gauss Elimination. The input should be the matrix A and with the B. First, I wrote a rule for this function. In order to solve the system using this method, the matrix A must be square. So I compare the number of the row and the number of the column, and if it is not the same number, the code will return error and end the function. Next, we need to combine the matrix and vector, so I create a new matrix here. I will combine the matrix A and vector B. So this is the an augmented matrix, and NAB is the number of column of the augmented matrix. So this will be equal to n plus 1, because n is the number of the column of the matrix A. Now in order to solve in order to get this new augmented matrix, we need to use loop, and the first loop will run through the column number 1 to column number 3 in this particular case, because we need to eliminate the coefficient from column number 1 to column number 3 right here. So this value will be n minus 1. And next we will run through the row number 2 to row number 4, but however the row number the loop for row I mean the loop for each row is not the same. First, take a look at this. This is the first loop. The number of the equation here has 3, and then become 2, and then 1. So the inside loop here will be start from 2 to 4, because we have 3 equation, and then it reduced to 2. So the starting number here will depends on the number j here, and it will vary from time to time. So only one step. So this now value here is j plus 1. Now take a look at this equation. First, I will talk about this factor here. The value here is from the value right here. As you can see, the 5, 6, 8 is from the value of the matrix AB, row number 2, 3, 4. So for this loop, we will change the row from I from j plus 1 to n, and the column it will change from 1, 2, and 3. So it just j. And for this value, as you can see, for the first loop, it does not change at all, so it will stay the same, and the number of the row and column is the same because we use the value from the diagonal here, 9, and then minus 2.444, and so on. So the number of row and column is the same, and in this case is j. And then the value AB here, it's the number for each row for every loop, but it should be contain the number for all of the column. So this one is from 1 to the number of the column of the augmented matrix, because as you can see, we do the calculation for the last column of the matrix as well in order to solve this system. And this is also the same. Now after run this loop, we can get a new augmented matrix, and you can solve by using back substitution here. First we solve for the value of z, y, h, and the last one is w. So first we solve for the last value here. M is the number of the row of the vector A, so this will be 8, 4, and we just use this number to solve for the z, and then we continue to solve for y, x, and w. As you can see, we can use loop here. So the loop will start from the highest number to the first row, and this case is number 1, and it changed from the higher value to the lowest. So in this case the value here is -1, and the last the solution that we need to solve, we use the row that is nearest to the last row. So in this case it will be n-1. So we'll start from the value 3, 2, and then 1. So this will be the edge number 3, number 2, and number 1. Now let's take a look at this first. This one is the diagonal matrix. I mean the diagonal number of the augmented the matrix of the matrix A. So in this case will be 9 minus 2.4 minus 4.0 and minus and then we can solve for the equation here. And you if you notice, for the first loop this only has one term, and then it becomes 2 terms, and then it will become 3 terms. So in this part the value contain the value in the column from column here, 2 column here, and then 3 column here, and then take the 4 column here for the last case here. So the first loop will be, the first term will be the using this number and multiply by the solution y, multiply by the solution z, and then we use the solution z and y multiply by this, and so on. So the value here will run from I plus 1 to n, then I plus 1 to n as well for the its value here. So we can solve for the solution by using this equation. And now we finish the Gauss elimination code. So I will run this code just to show you. I have already typed the matrix A here, and the vector B. It is the column vector, so I put the transpose here, and I will solve for the solution. So this is the solution of the X. Now I will show you a little bit more about the augmented matrix. So I just want to show you the final augmented matrix after this loop. Now we run this again. Sorry, let me try it again. So this is the augmented matrix, and as you can see, the value for the first row here is eliminated. Also this one here, this one also. So it's the same result that we got from the hand calculation here. So that's it for the Gauss elimination method, and I hope you guys get the idea. Thank you for watching. I see you guys in my next video.